to handle the multiple complexity, like I already told you, if this is the conditional probability, that is P of A intersection B upon P of P. So this is the conditional probability that we are calculating. But in naive Bayes we have to use the Bayes theorem, which is based upon the multiple conditional probability. Let us suppose, for example, let us suppose you have three companies which producing the standard scooters. So the standard scooters as well as the normal scooters, and you want to calculate the standard scooter, but there is a condition, multiple condition, that it must be come through the second plant. So this kind of questions is basically, or algorithm is used, type of complexity is used in the Bayes theorem. So hope you understand. So Naive Bayes is also called the Naives because it assumes that each input variable is independent. This is the strong assumption, all the unrealistic and for real data. Nevertheless, the technique is very effective on a large range of complex problems. So let us move towards the next one, the k nearest neighbor problem, that is the sixth one, which is a very important algorithm used nowadays also. Predictions are made for a new data point by searching through the entire training set for the k most similar instance. In k nearest neighbor algorithm, basically we search for the similar, we search for the similar set for similar instances, and summarizing the output variable for those k instances, we make basically the cluster. So having things that have the similar properties. For regression problems, this might be the mean, and also we can use the statistical techniques for that. For regression problems, this might be the mean output variable. For classification problems, this might be the mode. So for k nearest, we choose the k as a mean of the the objects, or if there is a classification problem, then we choose k as a mode. Mode is the highest frequency that get repeated again and again. So this is how the k nearest neighbor algorithm is used. The trick is in how to determine the similarity between the data instances. The simplest technique, if you all attributes are all of the same scale, all of the inches, for example, it is use the Euclidean distance, a number you can calculate directly based on differences between the each input variable. Euclidean distance, there is a term, I already made a video on this, what are the different kind of distances. If you never watched that, I'll advise you just go and watch that video, but for the sake of simplicity I'll explain once again what is the Euclidean distance here. Euclidean distance is nothing but the distance formula that you learn. X1 y1, there is a one point, and another point is b, which is x2 y2, and you know how to calculate the distance between these two, that is y2 minus y1 whole square plus x2 minus x1 whole square. So this formula is basically used to calculate the distance between the 2 points, and the same we can use to for the k algorithm, k nearest neighbor algorithm. So the idea of the distance or closeness can be break down in a very high dimension lots of the input variable, which can negatively affect the performance of the algorithm on your problem. This is called the curse of the dimensionality. It suggests you only use those inputs variable that are the most relevant to predicting the output variable. This I already covered in the last algorithms. I explained you have to, from the out of the various columns, you have to pick only those which have a highly relevant and have a use, and it should not be repeated again and again, otherwise it will make the algorithm more complex and more complex. So let us move forward. Learning vector quantization, this is again a very important algorithm used for a machine learning. The representation for the LVQ, it is also in the short, it is termed at LVQ. LVQ is a collection of the code book vectors. These are selected randomly in the beginning and adapted to the best summarize the training data set over a number of iterations of the learning algorithm. After learned, basically here you club the data in the form of vectors. So basically to do the data, let us suppose there is so much data, so we made them in a vector rather than to take it, this how we can reduce the iterations also. After learn, the codebook vectors can be used to make the prediction just like a k. We just first of all created the vectors, and then we can use k nearest neighbor to for the classification. So this how The class value or the real value in the case of the regression for the best matching unit is then returned as a prediction. Best results are achieved if you rescale your data to have the same range, such as between 0 and 1. Basically, in LVQ, we first of all convert the data into the vectors, and then we use KNN algorithm for classification. So if you discover that KNN gives good result on your data set, try using LVQ. This is because to reduce the memory requirement of the storing the entire training data set. I think you understand, because here we are not using the whole data set, we converted the whole data set into the vectors. That's why it is also called LVQ, learning vector quantization. Quantization, if I explain you the term quantization means what? Quantum means the packets. Quanta is a term that means the packets. So quanta, we convert the whole data into the smaller packets so that it get easily get trained, and we have to spend that is not only speed up the process but also save the cost. So let us move towards the next, the sport vector machine. A hyperplane is the line that splits the input variable space. In SVM, a hyperplane is selected to best separate the point in the input variable space by their class, either 0 or class 1. In 2 dimensions, you can visualize this as a line, and let's assume that all of our input points can be completely separated by this line. The SVM learning algorithm finds the coefficients that results in the best separation of the classes by the hyperplane. Hyperplane is what? I'll explain you. Actually, let us suppose in binary, let us suppose we have a data like this. We have a data like this, cross 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 and 0 0 0, and you want to segregate them. Some zeros are here also and some crosses are here also. So the one thing is, if you want to classify into binary with the linear regression, logistic regression, it can be divided like this. But if you want to completely divide like this, so here this kind of division is what we call hyperplane. Hyperplane is a solid line, splits the input variable spaces. In SVM, a hyperplane is selected to the best separate. I think you understand this. Hyperplane is separated the two things very clearly with each other. So the distance between the hyperplane and the closest data points is referred to as a margin, that the boundary by which the data gets separated out. Let us suppose these are cross, and this is how they are divided. The best optimal hyperplane that can separate the two classes is the line that the largest margin. This can in the algorithm in which the distance is the separated distance is fine, very fine. That is what we call best hyperplane. Only these points are relevant in defining the hyperplane and in the construction of the classifier. These points are called the sport vectors. These points is basically what we call the sport vectors. The sport, or defined as a hyperplane, in the practice an optimization algorithm is used to find the value of the coefficient that maximize the margin. Hope you understand. This is very clear. If you have a doubt, I'll cover all this topic with and it is better clarify only when I made a practical implementation of all these algorithms. So SVM might be one of the most powerful out of the box classifier with words trying on your data set. So I'll show you how and why SVM is better. So just wait. So the next one is the bagging and the random forest. Random forest is again one of the most important algorithms used in the machine learning nowadays. Random forest is nothing but it's also a classification algorithm. We already learned the decision tree. And tree is what? Tree is like where there is a root and there are leaves. But if let us suppose we have the number of trees together, what is this called? The number of trees or the trees, and if we club the number of trees, that is what will become a forest. So random forest is one of the most popular and most powerful machine learning algorithm. It is a type of the assembled machine learning algorithm called bootstrap aggregation or bagging. The bootstrap is a powerful statistical method for estimating a quantity from the data sample, such as mean. You take lots of sample of your data, calculate the mean, then average all of your data means to give you better estimation of the true mean values. So by bagging or by bootstrapping aggregation, we can it is used to make the same to increase the data your training data. How? by using the statistical technique. I'll make one video on this also for bagging, how this bagging is done or bootstrapping is done to make the data more effectively and more productively. So random forest is the tweak on this approach where decision trees are created so that rather than selecting optimum split points, suboptimal splits are made by introducing randomness. So that's why it is called random tree, because random forest is because we are taking the trees randomly, not any sequentially. We just classified the different trees together, so and randomly. That's why it is called random forest. The models created for each sample of the data are therefore more different than they otherwise would be, but still accurate in their unique and different ways. Combining their predictions result in the better estimation of the true underlying output values. So move toward the last one, the boosting and the ADA boost. Boosting is an assemble technique that attempts to create a strong classifier from a number of weak classifiers. This is very important. Boosting means what? To increase, somehow to increase the energy of something. That is what we call boosting. So here the weak classifiers are boosted with this algorithm. This is done by building a model from the training data set, then creating a second model that attempts to correct the errors from the first model. This how boosting is what? If you tell somebody their problem, then they will come up with the new solution and with to cope up that problems. So this how it get boosted, or what we call the amplify. So models are added until the training set is predicted perfectly, or a maximum number of models are added. So this is very important. Boosting is also one of the algorithm which is very important to increase the accuracy of the particular training set it is used. ADA boost was the first really successful boosting algorithm developed by the binary classification. It is the best starting point for the understanding boosting. Modern boosting methods build an ADA boost, most notably stochastic gradient boosting machines. So move towards the next one. ADA boost is used for short decision trees. After the first tree is created, the performance of the tree on each training instance is used to weight how much attention the next tree that is created should be pay attention to each training instance. Training means first of all you train the data, and after that you can find out how much there is a noise, or there is a conflict between the main what we call the errors. So the next time we minimize the errors by calculating from the first instance. So training data that is hard to predict is given more weight, and the training data which is very hard to predict, we will give them the more weight, whereas easy to predict instances are given less weight, and those who can easily predict, we will give them the less weight. So this how I think you understand how you can increase the accuracy of the particular data set. After all the trees are built, predictions are made for the new data, and the performance of each tree is weighted by how accurate it was on the training data. So hope you like this video and understand the different algorithms that I discussed here. This is very important to learn before starting any kind of machine learning, and if you know how to run this, first of all you have to understand the basic concepts behind them. Like I discussed in this video linear regression, or maybe you are watching the second part, so some of the algorithms are discussed in the previous one. I request you to just go and watch that video also, so that you have a complete understanding about how the different algorithms which are most popular used in the machine learning, and I'll advise you to just apply and learn and understand how to apply these kind of algorithms on the machine data. Hope you understand and like this video. If you like this video, just share it with your friends, so that that will motivate me to create certain more energetic and useful video for you people. Till then, thank you and stay tuned. Bye bye.